Hello, I'm Allis, and I'm a Senior Staff Associate at the International Research Institute for Climate and Society at Columbia University in New York. At the IRI, I support the development of decision support tools and climate services for decision makers in various sectors. In my presentation today, I'm going to provide a brief summary of El Niño, illustrate a few examples of impacts from previous years, and provide guidance on how to prepare for an El Niño. So what is ENSO and what is El Niño? ENSO stands for El Niño Southern Oscillation and is the periodic warming and cooling of the surface waters of the eastern and central Pacific Ocean around the equator. El Niño refers to the warming phase of this cycle, and during an El Niño event, warmer than average sea surface temperatures are often found off the coast of Peru and extend toward the western tropical Pacific. Conversely, La Niña is the cooling phase, referring to the colder than average sea surface temperatures in the same region. ENSO has an irregular 2 to 7 year cycle. Once developed, El Niño conditions in the Pacific typically persist for about 9 to 15 months. An El Niño event normally starts around June and peaks sometime between November and February. Peak impacts, however, do not necessarily coincide within the November to February timeframe, as societal impacts generally occur during a region's main rainy season, as that is when the disruption of the rains through failed or false rains or too much rainfall can have the greatest impact on agriculture, livelihoods, food security, and health and safety. One of the most popular indices used to check ENSO status is the Niño 3.4 index, which represents sea surface temperature anomalies in the Central Pacific, roughly shown in the black box on the right. While there isn't consensus in the scientific community on how climate change will impact ENSO, a new study suggests that while the overall number of El Niño events is unlikely to increase, particularly strong super El Niño events are likely to occur twice as frequently in a warming world. Specifically, the results show that the likelihood of super El Niño events doubles from 1 in every 20 years in the previous century to 1 in every 10 years in the 21st century. The strongest El Niño ever recorded occurred in 1997-1998. It led to heavy rains across the southern U.S., landslides in Peru, wildfires in Indonesia, and the cratering of the anchovy fishery in the eastern Pacific. These and other impacts were responsible for an estimated $35 to $45 billion in damage and 23,000 deaths worldwide. Typical hallmarks of El Niño in South America are extremely heavy rainfall and floods in Peru and Ecuador. In Peru, it is estimated that the 1997-1998 El Niño caused $3.5 billion in economic losses. The coastal waters of Peru is home to one of the world's richest fisheries. In normal years, winds from the southeast push warm surface water away from the coast, and in its place, upwelling brings to the surface cold water that's rich in nutrients, that supports plankton, a staple for the anchovieta fisheries. During El Niño events, the nutrient-rich cold water is replaced with nutrient-deplete warm water. Populations of fish and seabirds vanish, and anchovy catches dwindle during these events. During the 1997-1998 El Niño, it is estimated that Peru's fishery exports dropped by 76%. The intense rains caused major flooding and mudslides, which damaged roadways and other structures. And the Pan American Health Organization also cited a significant increase in cholera cases in the northern region. In Indonesia, the 1997-1998 El Niño is estimated to have caused $5 to $10 billion in economic losses. Indonesia experienced below normal rainfall, which contributed to conditions that resulted in the massive uncontrolled spread of peatland fires, which caused major regional haze, millions of cases of respiratory problems, thousands of hospitalizations, and visibility hazards for both air and sea navigation. According to published research in Nature, these fires accounted for the equivalent of 13 to 40% of global carbon emissions from fossil fuels during that time. The rainfall deficit started in March 1997, and the ensuing severe drought resulted in the malnutrition crisis and food shortages for hundreds of thousands of Indonesians. These factors almost certainly contributed to the political unrest, riots, and ultimately the president's resignation in May 1998. The 1997 and 1998 El Niño impacts in Peru and Indonesia are only two examples from a severe El Niño. And as Paula mentioned in her presentation, no two El Niño events are the same in terms of impacts. Furthermore, caution should be exercised when attributing cost to an El Niño event. The economic cost of disasters during ENSO neutral years may in fact be similar. The difference is that during El Niño and La Niña events, we have better forecast predictability and thus more opportunity to mitigate disasters. The next sequence of slides illustrates the timeline and actions the government of Indonesia took to prepare for a later El Niño, the El Niño of 2006-2007. The government took a number of steps to prepare in advance, but this series of slides focuses on their preparedness activities for the agriculture sector in Indramayu. In August 2006, the Indonesian Agency for Meteorological, Climatological, and Geophysics, BMKG, which was then called BMG, issued an El Niño forecast advisory. BMKG's October 2006 monthly update again confirmed the increased chance of an El Niño event. The El Niño advisory raised red flags in Indramayu, as 90% of the drought years in this district are linked to El Niño events. Under normal conditions, Indramayu has two growing seasons, with the first rice planting season starting in October and the second planting season starting in April. Under El Niño conditions, Indramayu typically experiences a delay in the onset of the monsoon in the first season, which delays planting in both the first and second cropping seasons. The delayed planting in the first season leads to increased chance of flooding during the first season's harvest and delays in planting crops in the second planting season, in addition to drier than normal conditions. This causes losses in the harvesting of the first crop and less than ideal growing conditions in the second crop, which also adversely impacts yields. Following BMKG's October 2006 forecast, the Ministry of Agriculture convened a multi-agency meeting to prepare action plans to manage the potential impacts of an El Niño. During the meeting, stakeholders discussed and formulated management options to support the agriculture sector. These management options were communicated by the head of the district to the sub-district heads. In October and November, the district and sub-district started implementing the early action plans. The early action plans included proactive measures such as the government securing agreements with agricultural input distributors to provide sufficient fertilizer and seed stock to support early planting. Governments also encouraged farmers to clear farmlands of rats, pest, and disease, as well as irrigation canals before the monsoon rains, so that planting could commence as soon as the monsoon started. They also established a revolving fund from which farmers could take out a loan without interest that could be paid back in 2 to 4 seasons. The loan would support the implementation of management options in the 2007 dry season. For example, they're switching to soybean or maize instead of rice. The local governments paid for additional croplands to be planted with soybean and maize, and the central government supported the provision of maize and soybean seeds. The governments also brokered agreements with the private sector to develop a market for soybean and maize crops. In late 2006 and early 2007, the Ministry of Agriculture and BMKG continued to evaluate the seasonal climate forecast to monitor climate risks for 2007. In March and early April of 2007, the government again deployed early action plans, including the planting of alternative crops such as soybean and maize in anticipation of the drier than normal growing season. While these actions did support the district achieve optimal yields in a dry year, an important lesson was learned. While governments did contact the agricultural distributors early to advance the availability of inputs such as fertilizer and seed stock, the government requires a competitive tender process for making awards to distributors. In some areas, the tender process was slow and key agricultural inputs were not available in advance. I also wanted to present an example of what individuals are doing to prepare for the potential El Niño later this year. In early July 2014, the United Nations Environment Programme's Regional Office for Africa set about organizing the ENSO East African Task Force. This task force will evaluate the historical ENSO impacts in the Greater Horn of Africa, analyze current climate forecasts, develop a climate vulnerability assessment, identify no-regrets measures, including ecosystem-based adaptation solutions to enhance food and water security in the region, and develop a strategic framework of action to guide agencies, governments, the private sector, communities, and persons in collective preventative actions and responses. The logos of the agencies and institutions involved in the task force are provided below. The following slides highlight a few recommendations on how to prepare for an El Niño. A good first step is to understand and assess how El Niño events can alter the risk in your area. It is important to identify which populations or geographic regions are vulnerable to climate variability. For example, areas of high flood risk or drought-induced food insecurity. Check out El Niño events have affected conditions in the past. For this, I have provided a list of the most recent El Niño years. Evaluate the relationships between El Niño years and agricultural yields, disaster incidents, reported malaria cases, and work with specialists to develop risk maps. I've provided a few resources in the following slides to get you started, the first of these being the IRI's ENSO resources page. Another good resource is NOAA's Climate Prediction Center, which issues weekly ENSO updates. For Latin and South America, a good resource is the International Center for the Investigation of El Niño. Australia's Bureau of Meteorology is also another great resource. After assessing how El Niño events can alter the risk in your area, a good next step is to develop risk management strategies that address vulnerability to climate extremes. An important aspect of this step is to foster communication between the National Meteorological Service, researchers, vulnerable groups, and boundary organizations, perhaps through an El Niño task force. Such a task force should develop strategies and review existing emergency plans against potential El Niño impacts. This task force should develop no-regret strategies that are beneficial to vulnerable populations regardless of the occurrence of the El Niño. If the National Meteorological Service is forecasting the high likelihood of dangerous conditions, such as a heavy flood or drought season, support early action through pre-positioning relief items, enhancing preparedness through training, develop contingency plans, and launch pre-emergency funding requests. The third step is to follow climate and weather forecasts between now and March 2015. Because the progress and strength of the El Niño can be monitored through near real-time ENSO observing systems, it is possible to generate probabilistic seasonal climate forecasts months in advance. These can be useful for planning strategies to mitigate impacts. Some national meteorological services can provide forecasts on multiple timescales, for example, seasonal, monthly, weekly, daily, etc. They can also provide information about how the potential El Niño and other climatic influences are likely to affect rainfall or temperature in your area. It is good practice for preparedness to follow the forecasted climate for your area, as conditions may change and the understanding will become more refined as we progress into the season. The fourth step is to develop communication and response plans. El Niño events and their potential impacts on society may be ignored or over-sensationalized by the media. It is important to work with the national meteorological agencies to establish clear and consistent messages that keep response organizations and the public informed about potential rainfall and temperature anomalies and to keep the risk in perspective. And the final step is to monitor and evaluate the effectiveness of interventions that use climate information in their design and execution. Intervention evaluation will support evidence-based policy, improve national and local preparedness, and prevent avoidable negative impacts associated with future El Niño events at the global, regional, and national scales. In closing, I would like to state that a major potential benefit of El Niño years is that the climate is likely to be more predictable. So keeping close tabs on the forecast products can help you craft early preparedness efforts and effective response plans to produce optimal outcomes in a year that is typically characterized by climate extremes. Furthermore, there are typically winners and losers in El Niño years, so it is possible that you reside in an area where increased rainfall events might be a boon for sectors such as agriculture through increased yields. Monitoring the event as it progresses offers your best chance at hedging risk and exploiting opportunities. This concludes the El Niño webinar and wrap-up. I hope the webinar has helped advance your understanding of El Niño and provided you with practical steps to help you reduce vulnerability and manage risk in your area.